So to explain the flip card method, I've made a sample set here. You can see that for Avogadro's number, I have 6.022 times 10 to the 23rd atoms, molecules, squid, whatever, for every 1 mole, and the reverse is also true on the other side. You can see that the way this works is that when you flip it this way, it shows the reverse relationship. And this is the part that students often have a hard time conceptualizing, that relationship goes both ways. And I did the same sort of thing for molar mass and for molar volume, which are 3 relationships we use a lot in stoichiometric calculations. Now, to see an example of how you might use this, I've got a sample problem that I might ask students to solve. What is the volume of 35.25 moles of helium gas at STP? Well, in order to solve that, students are going to usually use some sort of dimensional analysis, and starting off with the moles of helium gas, they can use these cards to figure out, well, which sort of relationship am I looking for? I want to know the volume. I know moles, so I'm talking about molar volume. And very easily becomes apparent that you're going to multiply by 22.4 liters and not divide. And this right here is often helpful for students to, when they're first starting to learn how to identify that these are proportional relationships, that they're reversible, and to actually be able to manipulate this. So I have students do this themselves, manipulate it and figure out, oh, should I divide or should I multiply? To give you an example of a more complex problem that students might be able to solve, what is the mass of 1.0 times 10 to the 10th atoms of mercury? This is going to be a 2-step sort of calculation. I realized I didn't write a line here. Should be a line right here. Well, students can very quickly realize if we know atoms and we want to know mass, molar volume has nothing to do with it. We can get rid of that. But at this point, oftentimes students find themselves kind of stymied. Well, what do I do first? Do I do Avogadro's number? Do I do molar mass? Is it multiply? Is it divide? It's just a big mess. I don't know how to come up with a plan to get from atoms to grams. All right. So here, this starts to fit together. We're fitting the pieces together by dividing by Avogadro's number. Now we're getting to moles, and then, well, that gets us to moles, but we want to know atoms, or excuse me, we want to know grams. And if we divide by grams, that's not going to get us moles. We're going to want to multiply by grams. And so you can see that students could use this method to help support dimensional analysis of more complicated problems. And I've used this method to help students with these sort of conversion problems. Obviously, you could use it with any sort of conversion problems, like how many liters are in 53,750 milliliters. Well, students may know that there are 1,000 milliliters in a liter, but may not intuitively know whether they should multiply or divide to convert. And this sort of visual aid can be really helpful for students who need that manipulative, something they can move with their hands or see it move in order to make that connection.